Fantastic. So I'm Albert. I've been with Thoughtworks for a bit more than 3 years now. Actually, I joined Thoughtworks on November 2018. So this is my third November in the company. I'm a lead consultant with Thoughtworks, and I love Java, as you will see from the slides. So what we're expecting today. So we're going to touch three topics. So first of all, we're going to understand why migrating from one version of Java to the other. Why is that unique when compared to our daily chores? Because we work on software continuously. Our software is being modified and changed on a daily basis. Why this change is so particular? Then we're going to see some scenarios where things can go wrong. And sometimes these are unexpected scenarios. You wouldn't expect that this is going to happen. And these are some sort of eye-openers. So you should look into these and make sure, like double check that this is not happening to your system before even starting the migration. And then we're going to talk about a strategy that you can adopt to migrate from a version of Java to the next one. We're going to see some examples here. I'm not going to do live coding. But all the examples that I will be sharing in the slides, they are available to download from this repository. We can make this repository available, the link to this repository available later on as well. So as Jenna said, if you have any questions, please ask them the minute you have them, and I will try my very best to answer them. So let's start. What's so unique about Java versions migration? Let's look a bit back at how we build software. So let's say we're starting this application. We start with one feature, and let's say this application is going to be deployed in on a container environment. So one of the first things we're going to do is we're going to have a simple application that responds to a health check and readiness check. Because once this is deployed, the container is going to use these endpoints to determine whether our application is healthy or not. So one of the first features we may develop is just this. And usually you're going to work on this feature, you're going to try it out, you're going to see it working on your machine. Hopefully you're going to write some tests against it, and you know that what you're working on, it's working well. Once that's ready, you're going to add a second feature to it, and you're going to repeat this process. Hopefully you write a test, you are building this feature, you're adding the dependencies that you need. But you're slowly growing it and you're seeing it happening. And you do it for the next feature, for the next one, and so on and so forth. And slowly you start building the application. And the application, you will be adding features at a slow rate, you're trying them, etc., etc. And we come up to an application now 1 or 2 years later with lots of features. A Java version migration doesn't go with this flow. As you notice, our application grew slowly with one feature at a time. And each time we added a new feature, we were seeing this feature being developed. When we do a change, a version change, this is going to happen. As you notice, we went from building something slowly like this into a complete change. But you're going to tell me, yeah, but like, why is that? Like, that shouldn't be a big problem. It's okay that we switch, from Java version 8 to 11 or to 17. That shouldn't be a big deal. And in theory, yes, it should work seamlessly. But unfortunately, that's not real life. So what can go wrong? And here I have some cases. These are not the only cases that can go wrong. These are just some examples. So there is this big question, like, is Java backward compatible? And the answer is yes. In general, Java is backward compatible. But that's not always the case. So let's look at this example here. Here we have some RMI code. This is running on Java 11, as you can see down here. And when I built my application, it worked. I'm going to switch this to Java 17. As you see here now, this became Java 17. This is the same application. When I tried to build it, it failed. The problem is that the RMI activation package was removed in Java 15. Java doesn't remove lots of code. It doesn't change the code so drastically that you will, your application will stop working. But there can be cases where, code is retired, as we see here. Of course, in this case, they retire code, which it requires lots of effort to maintain, and it's not being used a lot. But these cases exist. And you need to be certain that you are not depending on some code that is going to be retired. I know that many of you, they're going to tell me that we never worked with RMI. So can we get another example maybe that doesn't rely on RMI? And here I'm going to give you another example using a very, very well-known or popular dependency, which is the Lombok dependency. Here I have a simple class called appointment. It uses data annotation and the builder annotation. I'm using the Gradle with the Lombok plugin, and my Java version is 11 again, and Lombok version is 1.18.12. And as you see down here, it builds. It works. I have no problem. If I move to Java 17, as you saw here, I kept everything the same. So it's still the same plugin, it's the same version of Lombok. It will not build. So by simply upgrading Java, Lombok stopped working. And that's because officially Lombok 1.18.22 supports Java 17. So if you want to move, if you're using Lombok and you want to move from 11, for example, to 17, you need to update Lombok. And you're going to tell me, yes, but we can update Lombok. Like we should have the latest version of Lombok. Why not? And that's a good train of thought. But unfortunately, nothing goes as planned. So new versions of a dependency may not play well with other versions, and with other dependencies. And as you may anticipate it here, Lombok may not play well with others' dependencies. And this is very tricky because Lombok is generating bytecode for us. So here I have an example using, this example I am using Jackson and Lombok. So here I have the same appointment class. This time I'm using a builder with the JSON Pojo builder here. And I'm also specifying the pattern that I'm expecting this timestamp to be. I have a test here. You see this test is providing the date, good name, and the timestamp in this format. I run it with Java 11 and the 18.12, and the test works. So this code is working perfectly. I switched this to Java 11. I switched this now to 18.16. It's still Java 11 because before I move to Java 17, I need to bring this up to 18.22. If you remember from some previous slides here, 18.22 supports Java 11. So let's go forward. So here I simply switched from 12 to 16. I skipped 14 because 14 was a problematic version. They tell you not to use it. So this would be the next version bump for Lombok, and the test will fail. Nothing changed. So the only thing I changed, I bumped Lombok from 12 to 16. And remember, I needed 22 for Java 17 to work. And this problem here and this test failed. Now, this is quite tricky because I know people who would tell you, listen, I will not test everything. I will not test code that heavily depends on third-party libraries. So for example, when it comes to parsing, I'm not going to test Jackson. If this code or this code is coming from an example or it is motivated from a problem I saw on a project. So this is a real problem, not something I invented. Of course, I simplified the example a lot here and just to pick up this problem. If in this case we did not have such tests, that they are covering every corner of our application, this problem wouldn't have been visible before production. And that's something that we cannot risk. We shouldn't discover bugs at production, because they can cost money, they can cost them reputation, frustration, an endless list of problems. So great. And we have tests here. And let's say that our application is well tested. We have all the tests we need. Are the tests really running? And this is another problem that I saw recently. So here I have a simple application. I have a class called algorithm, and that has an add function. And yes, it has an intentional bug here. I am not adding these two. So when I do A, instead of doing A plus B, I'm doing A minus B. Here I have my test. So algorithm add 2 and 4, and this should give me 6. And when I run this from the IDE, when I run it from IntelliJ, as you can see, it works well. It works well in the sense the test fails when it should fail. So I can rest assured that this test is covering my logic. So test run when triggered from the IDE. Now I went on Maven and I ran this code, mvn wtest. And if you notice down here, the test did not fail. You see, I have a build successful. But if you notice if you pay a bit more attention, you'll see that the number of tests that were ran was 0. So somehow Maven did not pick up our tests. And this is quite critical, because when you're developing, usually you simply run the test from your IDE. So if you're building a feature, for example, you just hit the run, the test to run the test from the IDE. And when you run the test from the command line, as we're doing here, you may not notice that some tests are not picked up, especially if you have a large number of tests, like in the hundreds. So what is this problem? This problem happens in here. The Maven Surefire plugin does not run JUnit 5 with versions 2.19.1 or before. So if your Surefire plugin is 2.19.1 or before, and you have a mixture of JUnit 4 and JUnit 5 tests, the JUnit 5 tests are not executed, even if these are failing. So you may think that you have tests which are covering you, and they are not. And of course, you're going to tell me, but listen, okay, this is a problem, but when you're developing, you're running them from the IDE, so you are certain that they are green. That's not correct, because let's say that you are working on a feature, and a few weeks later, I worked on another feature which is related to your feature, and somehow I am modifying your feature indirectly because of my feature's behavior. These tests are not protecting me. So I may think that I have this safety because of all these tests when I do not. So in this case, we need to make sure, we need to update Maven to the Maven Surefire plugin 2022.0 or above. Now, when I am developing with locally, initially, when I do a failing tests, I don't simply run it from the IDE. I trigger the whole flow locally. And this is how we detected this problem, because yes, from the IDE was working and it failed. And the next thing I did, I ran the full test, the full build locally, expecting it to fail, and it did not. And then we did the investigation and we found the problem. But that's not a practice that everybody does, because, you know, we go fast, you go from the IDE, you run things from the IDE, they work, and you think that you're covered when you're not. People were going to tell me, okay, but we have code coverage. And this is a very, very tricky or something that sometimes it's misread, in my opinion. So yeah, code coverage is a good tool. And especially when we're migrating from a version of Java to another version of Java, we need to make sure that our code coverage doesn't change. It does not increase nor decrease. If there are changes observed, there should be a reason. Change shouldn't come from nothing, and it should be understood. But code coverage is going to show you only one thing: what areas of the code you're not covering. Code coverage is not going to show you areas of code that you are covering. And this sounds very weird. So code coverage is only going to show you gaps. It's not going to show you where you pass, because that's a false sense of security. It's going to tell you your gaps. Why I'm saying this? Consider the following example. I have another algorithm. Yes, this is a very selected problem where it takes two double. This is the range from where it starts. The until is where it should stop, and the consumer. It's very straightforward. It starts from the from, and it keeps iterating until it reaches the until, and then it stops. Here I wrote a test for it. It's called run 4 times. I created a consumer, which basically my consumer is going to put it's going to collect the number of times the accept is called into a list. So when I create my algorithm and I run it between 1 double and 5 double, and I pass this consumer, it's going to give me a list containing these values: 1, 2, 3, 4. Because it's going to start with 1 and it's going to stop, because when I becomes 5, it will stop, it will not call it. And this works. And if you see the coverage, as you see here, it's 100% covered. But is this code correct? Of course, if it's here, it's not. Then I wrote this other test where I use these very silly large numbers. So now instead of iterating between 1 and 5, I'm iterating between billions and billions. And as you can see from the title, this code will run forever, or it will stop until you have a Stack Overflow or a memory problem. Why is that? Why this code doesn't work? And the problem here lies in the way float and double work. So let's see it in a better example. So here, I have another test, which is called var plus 1 should be greater than var. And that makes sense, yes, because if I have a number, a, and then b, which is a plus 1, should be greater than a, because b is a plus 1. As the IDE is already hinting, that's never the case. And the problem is because in double, this number doesn't exist. The number closest to this is 0. And the next number is 2. This number doesn't exist. So when I try to represent this number here, this is going to be represented as 1, 0, 0, 0, 0, 0, and 0. When I try to do a plus 1, that number doesn't exist. So a stays as it is. And that's why the infinite loop, from where the infinite loop comes, because this increment here doesn't really work, doesn't do the job that we're expecting it to do. Now, this example, I got this example from a very, very nice book called Java Puzzlers. If you like to know more about, these kind of problems with Java, there is a very good book by Joshua Block. It's called Java Puzzlers, Traps, Pitfalls, and Corner Cases. And I highly recommend this book to everybody. Now, but you're going to tell me, but listen, Albert, we don't have this kind of double problem. So this is not an issue for us. And that's very good. So let's see another problem. And this is an article by Joshua Block. This is the same author of the book. And when Joshua Block was involved heavily in the Java Collections API. And one thing that they realized is that the binary search used by Java had a very big flaw. And that's because this was copied from a book, and this algorithm in the book had a flaw. So the issue is in this line. And as you can see there, this can overflows. Why? If you have a very, very big array, and you happen to search in its upper half, not in the lower half, in the upper half, this algorithm will break. But as you see, this algorithm will break in a specific case. And these problems, they are more common than you think in our applications. And usually a set of conditions will make a problem appear, but these conditions, they are rarely tested. I'm mentioning this because code coverage can give you this false sense of security. As we saw before, here we had 100% code coverage, but this doesn't mean that our application is well or thoroughly tested. One last thing before we jump into the actual strategy. When you are updating, when you're upgrading from one version of Java to the next, you can go as fast as your slowest dependency. By slowest dependency here, I'm not referring to the speed, but how quickly they update. Let's have a quick look here. So Java 17 was released in September 14th of this year. Lombok version 1822 was released in 6th of October. So if you were heavily relying on Lombok, you could move to 17 officially on the 6th of October. That's not bad, but this can be a bit of a problem. If you are using long-term Java support, like Java 8, Java 11, and now Java 17, it's okay, you have some time to update. You don't need to update immediately when the next version of Java is released. But if you are on the bleeding edge and you are moving to the next available version and using the short-term support or the non-long-term support like Java 9, Java 10, 12, 13, 14, 15, and 16, if you're using any of these versions, note that the non-long-term support versions, their support stops immediately when the next release is out. So Java 15, the support for Java 15 stopped when Java 16 was released. When Java 17 was released, the support for Java 16 stopped. Now, it doesn't mean that Java 15 or 16 stops working. No, what it means is if there is a security update, this will not be applied to these versions of Java because they are not supported. So when using non-long-term support versions, be careful because you may require to switch to a newer version of Java, but your dependencies will prevent you from doing so. So in this case, it's advised to stick with the long-term support because, for example, Java 11 is still going to be supported for some time. You have time to migrate. Spring, which was very active in development and was adopting Java 17 even while it was early released. You know, in this version, for example, 5.3.11 fixed a bug which was related to Java 17. So that's another problem that you need to take under consideration. Yes, the library may support it, but it may still have bugs, you know, running in some corner cases, which they still need to be fixed. So in this case, it was fixed a month after Java 17 was released. Gradle, which is a very popular build tool, officially supports Java 17, officially started supporting Java 17 with Gradle 7.3, released in November, almost 2 months later. Jackson, which is a very, very popular library, still has open issues related to Java 17. If you're using Neo4j, for example, the Neo4j Java driver, up to date, it doesn't officially support Java 17. I know people may have tried it and it may work, but it's not officially supported. And the list goes on. Here I could only list some of these very popular tools. So we talked about problems. And now it's time to see how can we safely move from one version of Java to the next without disrupting production, ideally. So this is a photo of a production plant. And this photo, I thought about this photo because if you want to move from one version of Java to the next, you need to have a good build pipeline. Without a build pipeline, using tools like these here or any other tools, it's going to be very hard for you to move. And that's because the thanks to automation, we can automate tasks here and keep applying these tasks until we're satisfied, and we apply them with minimal effort. So let's see how a build pipeline usually works. When a developer is ready from some code, they push it to a central source version control, like GitHub, GitLab, or whatever. This usually triggers a chain of actions. So our build tool usually gets the code, compiles the code, builds the code, runs the tests, runs other types of tests, package the code, and then push it in production. We're going to see a very simplified flow next. And if one of these stages they fail, the production is halted, sort of. Developers are notified, and then they can act immediately. And this is something that we will leverage here, because as we're going to see, we will automate this bit and we will keep refining our application without breaking its current functionality, but also making it ready to move to the next version of Java. So let's assume we have a very simple pipeline. And it's with Java 8. We have the development stage here. This is the developers, the programmers' laptops or machines. Then once the code is pushed, it goes to the unit and integration test stage. Here we build the code, we compile the code, and finally we produce an artifact like a jar file. And the functional test, as we're going to see, we're going to run the application, but we run the application without knowing what the application looks like. We talk to the application from the outside. It's like you're talking to another person via a telephone. You're not seeing the other person. You don't know what they are doing. You're just talking to them via the telephone. And finally, the same application that was tested, if it was tested successfully, it moves to production. But there is an important distinction here that we need to make when it comes to Java. In the first two boxes here, we're dealing with source code, because we get in development and in the unit test, integration test phases. Here we are compiling the code. Whereas in the other two sections, we work with the bytecode. Now, for example, to run the functional test, we don't need the Java compiler. All we need is to run it. For example, Lombok, it doesn't kick in at this stage because the bytecode was already generated. Here, we're simply getting the artifact and run it. And this is how usually the functional test will work. So here I have a very, very simple Docker image using running on Java 8. It simply copies the application that was built in the unit test, integration test phase. And the functional tests are going to run against this Docker image. So in essence, this application, from the functional test point of view, it could have been a Node application or a Rust application, a Golang application. They don't know. And here is how it's going to work. So our application shown here, it's going to be wrapped inside a container. The functional tests, they cannot access the code of this application. The only thing they can do is interact with the application through the exposed ports. So our application, like it's a REST-based application, and the only thing that these functional tests can do is start the container and interact with it by making requests. Just to show you an example here. Here I have a functional test. This is written in Java. but my functional tests in Java, they're in a different place. They're in a different, they can be also in a different repository if you want. They're not part of the application. So here, and if you want, you don't even need to use Java. You can run these tests with Node if you prefer, or other libraries you like. Here I'm using test containers because that's convenient. At this bit, I am setting up my container and I am making sure it's running. Then I make a request. Here I'm just talking to I'm getting the actuator health endpoint. And finally, I make sure that I got the response I wanted. But here in this test, I am not interacting with the application. Again, the application could have been written in Node.js, in Rust, Golang, you name it. Because all I care about in the functional test is that my container goes up and running and it behaves as I want it to behave. So let's say I would like to switch to Java 11 because Java 8 is a bit old and we would like to move forward. One of the questions that people usually ask is, okay, why not jumping straight to Java 17? Like, why taking the hassle to first move to Java 11 and then move to Java 17? And that's a very fair question. So let's say that we are here. We are in Java 8. And this is Java 17. And this is the path to Java 17. This is the effort or the amount of changes or the amount of potential changes that we may need to do in order to move from Java 8 to Java 17. Java 11 is somewhere in the middle, let's say. It may not be exactly in the middle, but let's say it's somewhere in the middle. But definitely the changes that you need to do to make Java 8 compatible to Java 11, they are a sort of a subset. Of course, there may be some things which work in 11, but they will not work in 17. I am not aware of things that were introduced in Java 17 and they are going to be retired in Java 11. So any work you're going to do moving from 8 to 11 is not going to be thrown away. So here, the changes required for you to move from 8 to 17 are far less. The step that you need to make to move from 8 to 11 is far smaller than the step you need to do to move from 8 to 17. So instead of making this big leap, you can split it in two. Also, this is a learning process. You're going to discover issues during the process. The whole team is going to be involved and the whole team will learn from this process. So it's good that it's repeated because once the next version, the next LTS, which if I'm not mistaken is going to be Java 21, it's going to be released in 2 years' time, always if my memory serves me well, is going to be released. This process is going to be documented. The team is going to be aware of this, and then we can repeat again when the next LTS or the next Java version you would like to use becomes available. So great. Here we agreed that we're going to move to Java 11. As you saw, or the whole pipeline at the moment is working with Java 8. What's the first thing to do? So here, the first thing we need to do is create a new stream. Notice that in my pipeline here, I am not affecting the current production line. I am simply spawning like a new fork here. So I have two functional tests running. It's important to note that the same jar file that was produced by this stage, by the unit and integration test stage, is used in both functional tests. The same program that is going to end up in production after this phase here. So the same jar file that is going to end up in production, it's going to be used to test the functional tests. And this is very important. Also notice that the output of this functional test goes nowhere. So what's the use of this? And that's very simple. Usually the build pipeline also comes with some visual aid. We have some monitoring, something that we can see the pipeline, because if something fails, we want to be alerted. So the only way for us to see whether this test is working or not is through the UI, to the monitoring UI. If this fails, if this pink box for now fails, nothing happens. The code still moves to production. Why is that? Because chances are that when we create this new fork, chances are it's going to fail. It's not going to work as expected. But we don't want to stop production yet. Why? Because our production stream is still working on Java 8. The fact that it's failing on a newer version of Java, it's not affecting our production system. We're creating this fork for several reasons. Let's say we have a team of 6 or 8 developers. Are all these developers going to be working on the migration from Java 8 to Java 11? And chances are no. You don't need 6, 8 people to migrate. You need maybe 2 or 3 of them to pair and work together, but the rest can still keep developing features, which is quite important because nowadays we cannot stop changing our software. You know, the business side is going to continuously come with new requirements. We may have some bugs to fix, and that type of work needs to keep going. And this line, it's ensuring that this build pipeline is still ensuring that whoever would like to add code, they can still do. They can still do so without having to worry about this migration from Java 8 to Java 11. This migration is, thanks to this fork though, we know whether our application from a functional point of view can run on Java 11 or not. How we will do this? So before I showed you a Docker file, which was built on Java 8, as we see up here. Now I have a second one. So here I have two Docker images. One built with Java 8, the other one with Java 11. That's the only difference. Notice that here I'm using the same jar file. And this is very important. As I mentioned before in here, they need to use the same jar file because this is going to give us a window now. It's going to tell us whether our application, if we start this on a Java 11 container instead of Java 8, will it work as expected? Will the functional test return the same results as if you're running it with Java 8? And what's going to happen now? So we're going to keep modifying the software, keeping it compatible with Java 8 until all functional tests pass. So we're going to keep iterating, you know, the team or the subset of developers who are trying to get this migration done, they are going to keep maybe changing libraries, changing code, such that it compiles and works with Java 8 and also the functional tests pass. Once the functional tests pass, we move to the next stage, which is we spawn now the unit tests, unit and integration tests to their own branch. Notice how the pipeline changed now. Before we had this pipeline where both functional tests were getting the same jar file, the same jar file built by this stage, the unit and integration test with Java 8. Moving forward now, we have unit and integration tests running with Java 11. It's important to note that both unit and integration tests are using the same source files. So when the developer commits code, the code that was committed by the developer with no changes, the same code goes into both streams. The stream, of course, it doesn't lead to anything, it's just observed, and the other stream goes straight to production, or it depends how the team configured this. Again, initially we may not be some tests may fail and we need to tune, but it's very important that this whole thing needs to stay green. And the development environment, as you can see, this is still running on Java 8. Something I didn't mention before here, these colors are on purpose. So anything with this color is Java 8. Anything with this color is on Java 11. I hope it was clear without me having to say this. So how can we build this such that in here we run the tests with Java 11 and here run them in Java 8. And maybe for the developers who want to work on this migration, they would like to maybe try it themselves on their machine. So how can we accommodate this, keeping the same source? Now, one of the new features that Gradle came up with, starting from Gradle 7, was the toolchain. This is not the only option. Of course, one alternative is that in this environment, we install Java 11. That can be a step. So in this environment, we will have our Java home set to Java 11, whereas in this environment, the Java home will be set to Java 8. But this is a neat way where we can take advantage of from the Gradle toolchain. So before we were telling Gradle to use Java 8. This is how it was before. We can make a change in our toolchain where we can read a property from the command line. And if this property is set, here I'm giving it a default value of false, which means use the new version. So in this case here, if this is set to true, I use 11, otherwise 8. Now you're going to tell me why you're not specifying the version of Java in the property, because here I could simply say that instead of passing me a Boolean, pass the version of Java, 8 or 11. No, I want to control the version of Java used inside the code. I don't want it to be just as a parameter, because like this, there is no way, for example, that you, by mistake, try Java 11. Sorry, try Java 17, not 11. Why? Because the only flag you have is this new Java version true. You don't have other flags. And also when you're working like on your machine, instead of doing Gradle build, you just do Gradle build minus up new version true. And that's gonna rely on this, always on this code. And you're sure that if the flag is turned on, it's turned on for the version of Java that you want, not for any version of Java. Now that we have everything working, like all our tests or our unit tests are green, functional tests are green, we can now switch our production to Java 11. But this needs to come in with a condition. Different from before, where if this failed, we were still deploying. In this case, we only deploy to production if both work. And that's very important. There can be cases where our tests are not capturing a situation. And once we go to production with Java 11, in this case, we may discover a problem or a bug, or our monitoring will see that maybe we're using more memory than we were, or there were latency was introduced for some reason. You want to be in a position that you can easily switch back to Java 8 and resume your business seamlessly. And that's why you should not simply kill this stream once the unit test and functional test, they all come green. Because even though if you do work in test-driven development, if you have very good coverage, if you use mutation testing, what have you, there can still be cases which you don't understand or which you're not covering. Latency, for example, can be one of them. And you will only discover it once you hit production. So now we are in this situation where our pipeline is all running on Java 11. Our development, as you can see, is still in Java 8. So here, the source code does not yet use any Java 11 features. And that was important because if at this stage we start using Java 11 features, these two are going to fail. And you're going to make this like backup plan that you can switch back to Java 8 useless. Now, when you move from Java 8 to 11, I wouldn't kill this immediately. I would leave this pipeline running for a week or two before I move to the next step. And this is quite important because you want to make sure that, you know, at this stage, the Java 11 version, you're happy with it and you don't want to kill it immediately. So we are at this stage. The last bit that we have now, we switch to Java 11 completely. And we are, now the conversion is done. Are we there yet? Yes, almost. You remember this flag we had before that we were switching, we were parameterizing which version of Java to use. I would remove that. Make sure that any code that we have added in order to accommodate both versions is now removed because it's not needed. Don't leave flags that you may have added there to help you with the process because they can, that's code that if some code is there, I would ask myself, okay, why is this needed? Is it because we want a fallback strategy? And there can be cases where, you know, some code is forgotten there, the team is rotated, and then you're going to have code that nobody understands. Even if it's simple code, nobody would understand why you have this option there, and people will be afraid of removing it. So make sure that once the migration is complete, you clean up any residual code that you may have added just for the migration. So here we finished. So here we finished now the migration from Java 8 to Java 11. If we would like to push it forward to Java 17, all we need to do is rinse and repeat. You can use the same approach that we saw here. You start with Java 11, you fork in something new, functional tests. Then you, once they pass, you fork in also the unit integration test. Once that becomes clean, you make that as your mainstream. And then once everything is where you're happy with the performance, you're happy with the application, you can retire the Java 11 pipeline and have the full code Java 17. So this was this brings us to the end of the presentation. I hope that it was insightful. I hope that you learned something from it. I didn't hear any questions.
Thanks so much, Albert. Yeah, that's right. One second. We don't have any questions yet, but if everyone wants to give Albert a shout out for a great talk, this is a good time. Thank you so much. Yeah, and if you have a question, please ping it in the chat or yeah. I wonder how many people are going to be going through this migration process.
I think many, because now if you're using Java and you still, for example, on Java 8, it's good that you start moving to, for example, Java 11 at least. Java 8 is still still being supported, but the question is, okay, why should you migrate? And it's not just about features, because yes, Java 11 and Java 17, they introduce new features, which are quite nice to the developer. But there is also the performance side where, for example, new garbage collectors or improved performance was made available to Java. One in the past, if you see what takes your memory, for example, in Java, you'll notice that the Java strings, usually they take half of your heap space. And if I'm not mistaken, in Java 9, compressed strings were introduced, where if you're using just ASCII, which is usually the majority of our strings, if you're using ASCII, the string will use half of the space because it doesn't need the UTF-8 length. And whereas if, of course, you have symbols like umlauts, like we have here in German, in the German language, then of course you need to use the UTF-8. But like if you're saving my name in this case, or Jenna's name, you will use half of the space. So yes, moving from one version of Java to the next is quite beneficial. From a development point of view, it's because new API is made available to you, and also from a performance point of view.
Thank you. The first question then is when to migrate to Java 17. I'm not sure if you just already.
Yes. So let's say I have an application, it's running on Java 8. When should I migrate? And definitely I would start thinking of migrating to Java 11 first. Now, this is a bit of a business decision, because let's say that we need to release a new feature, a very important feature. Should I stop that and do the migration, or should I focus first on important feature? And that's a business question. So moving forward, it's going to cost us some time. What we can do is the strategy that I explained here, it doesn't need to be deployed all together. So if we have a pipeline set up, we can simply fork the functional test and we can stop there. And that can stay there for a month or two until we have now some more time to do it. So it's not something that you need to do in one big chunk. Now, when you do the functional tests, you're going to have an estimation of how much effort you need. And that's going to help you assess whether now it's the right time or not. Because it depends, you know. I would definitely not recommend somebody to, you know, halt improving their current project just to do a migration. And that's why we fork it, so that the normal development can still keep going. Also, because you need to keep the current pipeline green, you're going to move in small chunks, which even if you're fixing or moving towards Java 11 or Java 17, you're going to keep your application still working. So I would start, just to answer now this quickly, I would bring it to the team. I would see whether there can be some resources which can be spared to start the process. And then I iterate, because after, let's say after you do the first bit, you're going to learn, you're going to do an estimate of how much effort you need. You go back to the team and you can take it to the next iteration or park it a bit. If it does not answer your question, please let me know and I'll try to answer it again.
Thanks a lot, Albert. Okay, I can go until we hear something. I'll go ahead with Enrique's question. If there are many code changes for building the jar for Java 11, would you keep a different branch?
No. It's very important to keep the same branch, because let me go back. Because notice in this technique, the code needs to work on both of them. If you're going to keep two branches, that's going to have multiple challenges. The chances are that this migration will take you some time. I know that it can be very straightforward because of your project, but it can drag 2 weeks, if not months. So having branches, long-lived branches, then you're going to have a merge conflict problem, because this branch will become very stale. Ideally, this is on the same branch. Not only for that, if you split them in multiple branches, then you definitely cannot use this technique. Because here, notice that at this stage, when our unit tests are green, our functional tests are green, so all 4 stages here that you see in the middle are green. And we can decide whether we use this artifact or this artifact. If you keep 2 branches, how are you going to do this? So definitely, I would keep 1 branch. And I am an advocate of trunk-based development. Trunk-based development. I am not in favor of branches. I know it's not the topic of today, but I definitely recommend to consider trunk-based development over branches.
Great. Thanks a lot, Albert. All right. Then the next question is from Francesc. Sorry if I said your name wrong. And the question is, you have used Gradle, but if you use Maven, I suppose that migrate from Java 8 to Java 11. Do we need to use a profile with the proper plugins? Thanks.
Yes, you're referring to this, where is it? This trick here, yes. Offhand, I don't know. I don't have an answer for that, but there are two approaches. First, try to do it in the code using toolchains. If I am not mistaken, Maven supports toolchains. And if for those who don't know what the toolchain is doing here, so irrespective of what Java version you have set in your host. So let's say that here I have installed Java 8. Gradle here is gonna come and says, okay, I have Java 8. I did not specify anything else like vendors, etc. So it's gonna use my Java. But here it's gonna say, okay, like I need Java 11. I don't have Java 11. I know that on the host I have Java 8 installed. So Gradle here is gonna download Java 11 for me. To be honest, I don't know if here we'll also download Java 8 or use the one in the host. That I don't remember, but with the toolchain, irrespective of what Java version you have installed on your machine, Gradle is going to get the version of Java you specify here. If I am not mistaken, Maven supports the toolchains as well. Again, Maven is more popular than Gradle. This can be a bit of a tangent as well. Why I prefer Gradle? I prefer Gradle for two reasons. One, I prefer the Groovy or Kotlin syntax when it comes to configuration than XML. And secondly, which is more important, Gradle is faster. When it comes to building the application, Gradle is way faster. And this is the reason why I stick to Gradle.
Great.
But Maven is a good tool. Like I'm not saying Maven is a great tool, actually. Thanks to Maven, I think we have Gradle. Cool.
Thank you.
You're welcome.
All right, Paul has the next question. And first of all, I want to say thank you. So thank you for the insightful session. And the question is it advisable to migrate to LTS versions of Java if given freedom to choose the version?
If I understand your question correctly, should I consider non-LTS or should I just stick to the LTS versions? I don't know if they are still online and they can confirm.
We just got a yes in the chat.
Yes,
so
yes. Cool. Very good. So would I consider non-LTS like Java 9, Java 10, for example, Java 12, 13, 14, 15, or 16? And the answer, because I'm a consultant, it depends. And it depends what? If the LTS is going to give me a competitive edge from a business point of view, so let's say that Java 18, which is going to be a non-LTS, it's going to have this feature, which if we use it, is going to make us money. And only this feature is going to make us money. Then I have a business case. I can say, okay, I'm going to move to the non-long-term support, Java 18. I know that once Java 19 is released, the support is going to stop. It doesn't mean that my application will stop working. What it means is that I will not get updates. I will not get security updates. But here you see the risks are, I have tangible monetary income. Like I am going to make more money just because I moved to Java 18. If you cannot quantify, if you cannot see an edge, a business edge, I would not move to an LTS. But what you can do is this. You can use this technique to, let's say we're on Java 17 now, and we know that Java 18 is going to be released. We can still have this pipeline set up on standby, which is going to be running all our functional tests and all our unit tests on Java 18. So even though we are not migrating, even though we are not going to move to 18 because that's a non-LTS, for example, our application is future-proof. And once 19 is released, we switch these two. So we keep Java 11 as our mainstream. We switch these two to Java 19. We change And we make our application future-proof for Java 19, and so on and so forth. And like this, once 21 becomes available, we will keep simply update these two to 21. Once the LTS is stable and our application is green, we can simply push forward. But to go back to this question, I would only use a non-LTS if that's going to give me a business advantage. Otherwise, I would be careful because there are bugs that are fixed, security bugs that are fixed. One that comes to mind quickly, for example, are root certificates. Part of the JRE, there are going to be some root certificates, which then they are going to be used in authentication. And if there is a certificate which is retired and you never updated your runtime, you may still think that that certificate is still valid. And that can be a security problem. So this is why I would be careful. Now, if the non-LTS, it's going to give you a competitive edge and you still want to move forward, be mindful. So once it goes out of support, be ready. And usually Java, the new versions of Java are available as early release. So let's say that you want to adopt Java 18. So this is Java 18. As soon as the early release of Java 19 is available, fork this new pipeline. And this is why pipelines are very important, because you see how much you can automate and start becoming ready to support Java 19. So the minute it becomes available, you can easily swap to the next non-LTS or the next version. But be mindful with one thing. In here, we said that we are keeping both streams working, and we only go to production once both of them they're green. Now, let's say that this is version 18 non-LTS, version 19 non-LTS. If you are not happy with the outcome, you discover some latencies or something, your fallback version is non-LTS as well. So maybe in this case, something that you want to do is maybe you need to keep a third stream. So you keep an LTS build ready on standby. So when you're using the non-LTS versions, if you notice something that you're not happy with, you can fall back. But this is easier said than done, because usually you want to take advantage of some features that are available in the new version of Java. And if these features are language features, then you cannot do that. Because in order to keep compiling, let's say Java 18 has some new syntax. Of course, Java 17 doesn't accommodate this, so you cannot compile the code with Java 17. That will fail. I hope I answered your question.
Thank you. The next question comes from Lars, and the question is, thanks for the great insights, Albert. Any tips on how keeping library code compatible to Java 8 and 17 at the same time? We have multiple services that we want to migrate one by one, but they depend on some shared libraries.
That's a very big challenge. And yes, it's not going to be easy, because you may upgrade a dependency, and this is used transitively by different projects. So one of the things that you may need to do, or you may end up doing there, is isolating. And this problem here, maybe it comes from the way your services are designed. So this is more of a microservice related topic, but it's a very good one. And so if you start encountering problems because service A needs version, and when you bump it up, service B breaks, one of the things you may consider is splitting these dependencies. So they are depending, for example, on a service C or on a library C. Split it if possible. If it's not possible, I need to think more about this to give you a better answer. So if you want to leave me your email address, I'll think a bit about it, or maybe we can have a discussion offline, and maybe we can draft a solution. Because if you cannot split the dependency that is causing the problem, then it's gonna be a bit hard to move forward. And the issue here, it's mainly because of the design.
Great, thank you. The next question.
I am sorry if I did not give you a thorough answer.
I think Lars gave you a shout out in the chat. So far, everybody who asked a question, they said yes or thank you. So I think you're answering everything really well. Thank you. All right. And the next question is from Sebastian. And it is, what if you showed dependencies were removed?
I did not understand the question.
I'll just say it again. What if you showed dependencies were removed? Maybe if anybody can clarify, or Sebastian, if you like.
Yeah, if I understand it correctly, we have dependencies removed. So is it the question? Is it more that my code was using library X and now we don't need it anymore? Is this the question, or are you referring to these things? Something that was removed from the API?
Sebastian says yes in the chat.
From the API? Like this?
Can you give us another yes if it's for the API? Yes.
Yeah, that's a killer. If you are relying on these kinds of features, that's going to be a killer. But to defend the love of my life, which is Java, and no, my wife is not watching this stream. It's okay. I'm safe. Java, they introduced an annotation called, when Java, I think with Java 5, we had the deprecated annotation. And in Java 9 or 12, now I forgot, I'm sorry, they improved this annotation and they mark things for removal. So you know that this part of the code is going to be removed. So yes, when this was removed, this didn't happen overnight. We had time to look into this. One tip I'll tell you is that when you're compiling your Java code, please don't suppress the warnings. Actually tell the Java compiler to show you all the warnings. Because with those warnings, you start getting hints. If you are relying on deprecated code, it's going to tell you. And you can factor this in your daily life. Like when I say daily life, in your daily development life. So don't underestimate deprecated code. Worse than this, don't use code which was not intended to be shared. What do I mean by this? Why does Lombok fails when a new version of Java is released? It fails because it relies on internal parts of the Java API, which parts were not meant to be used by others. And since Java 9 and the introduction of the Java module system, this is going to become harder and harder as we go along, because Java is making it hard to use code which you were not expecting to use. And this is mainly why Lombok is failing there, because it's relying on code which was not meant to be used. Yes, this is very convenient code. Like I saw there is a class in Java called unsafe, and sometimes I see some funny tricks to use this class to achieve to try to squeeze in some performance. And it's not used with bad intentions, but yes, using code that you were not expected to use, that can get you in trouble. So one, don't turn off your compiler warnings. Make sure you have these on and listen to them. Factor this into technical debt, improvements into your API, and don't just be driven by features. It's important to maintain the code as you go along, not just with the Java API, also with the third-party libraries. I hope I answered your question.
Thanks. All right. Our next question is, would this make sense? Upgrading and versioning the shared libraries first, followed by the microservice upgrade.
Yes, I think offhand, I think it's a good strategy. Yes. And if this works well, you should be able to do it, because in this case, let me go a bit forward. Sorry about this. Oh. So in this case, your application is going to be built like your library. It's still supporting, for example, Java 8 and also supporting Java 11. The only downside would be, though, that let's say that your library here it's depending on library X. And you need to increase the version of library X so it will work with the new version of Java. But the new version may not work well with another dependency that the other microservice is using. And this can be quite tricky, because I don't know if I can draw it here. But you may, the problem that I was seeing when I was answering this question were the transitive dependencies. So I am pulling dependency A, and then also which depends on B. So I have both A and B, and I need to use B. Now with Gradle, I can tell it to exclude the transitive and import my specific version. But that can still put me in trouble, because the dependency A is relying on a newer version of dependency B, whereas my service needs the older version. And that's a bit problematic. Now, you can use a technology which is not very popular. The technology rather that Thoughtworks has discourages it. But one technology that can help you here is OSGI. I used OSGI in the past. It's fantastic, but it's not easy to work with it. You're not going to find as many resources. It's not supported well it doesn't work well with many libraries. So yeah, that can be a solution. Another solution would be to, instead of to package your dependencies, but here I'm thinking out loud. So maybe my answer, it's not well thought. Let's say take this with this in mind. What you can do is you can build this. No, you can't, because what I was going to suggest for the library, you can build a fed jar, but then still you don't know what the class loader is going to do. And that depends a lot on the class loader, because you can build a fed jar for the dependency and then include your other jar file. But then you may need to write a custom class loader where, when the classes are required by the other service, they use a version. And if they are needed by the other application, they use a different version. And even from the description, this is a bit complicated. I wouldn't recommend it. But I would be very interested in this case. And if you can share with me some details and maybe we can look into this together, I would be more than happy to do so.
Thanks a lot, Albert. Right now, I think we've gotten to all of the questions, and just I wanted to share what you shared, that if people do want to reach out to you, that's fine for you. You'd be happy.
Yes, of course.
Okay, that's cool. So
just, this is my email address, and you can reach me with your questions, and I'll try my very best to answer them as quickly as I can. I hope that you found this insightful. Of course, if you have feedback about the presentation, things you did not like, things you like, please share them. You can still send them via email. And I hope to see you in the next meetup. And that Thoughtworks, we have many meetups here. And I encourage everybody to join all the meetups they can join.
Thanks so much, Albert, for a wonderful talk. And thanks everyone for joining tonight.